Hello dear students, today we learn the analyze the fixed beam, this fixed beam, and draw the BMD and SABD. Now this is a beam, this is subjected to partial UDL, which is starting from the 3 meter and ends at the 8 meter. So this length is a 5 meter. That we know that this UDL creates a bending moment like this. Now here, if you consider a small element here of length dx and this load is 13 to dx, in that case we have a formula dma is equal to, now this moment both this ma and mb both are in the hogging nature, that is why is minus. We know this formula is W into dx, and now suppose this is the distance is the x and this remaining is the L minus x. In that case W into dx into A into this B square divided by L square. This is the W into dx is a small load. So this is the x, this is L minus x. What is the formula? Which is that we have taken from this when in any fixed beam subjected to our point load. In that case this MA is equal to WA B square by L square. So A is x and B is a L minus x. So W into dx, this is the total load, into x, this is A, this is the B square, and this is the W. So WAB square by L square. Now here we want the total MA, here distance, here if you take small element, we want the total element. That is why the capital M, total MA due to this partial load is minus integration, W is the 30 into x into L is the 8 minus x bracket square divided by 8 square into dx. Now the limit. Well, this is the starting of the UDL point. Start is from 3 meter. So right is the 3 ending at the 8 meter. So this becomes the a bending moment or fixed moment at the A due to this partial UDL. Now if we solve this, so this becomes, answer is minus 83 kilonewton meter. In the same way, if we consider this small element here, this, now the MB is minus W into dx. So this part is nothing but this total part is nothing but our capital W. Then the x square into L minus x is total divided by L square. So here this x square is nothing but the A square and this L minus x is the B. So the formula becomes W A square B by L square. But we want the total, so that is why again minus integration. Same is what is starting point is what? Is the 3. So is 3 to 8 minus 30 x square into 8 minus x is total divided by 8 square dx. Now if we calculate in the calculator, this value is minus 135.74 kilonewton meter. So we got the value of this MA, that is nothing but the minus 83, and here MB is minus 135.74. Okay. Now our aim is to now draw this BMD. For the BMD, we have to first draw the free body diagram, free bending moment. That is what? Consider the beam is simply supported like this. Suppose we consider here this beam is simply supported. Consider the beam as simply supported like this. And the distance is 5 meter, and this is 3 meter. This is A, this is B. So again what? Take here sigma MA is equal to 0. So this moment is a clockwise. So 30 into 5 into, now from here central distance is, this is 3 and half of this. So 3 plus 2.5, this becomes 5.5 minus here 8 RB is equal to 0. If you calculate this value, this RB becomes 103.125, and this RA becomes 46.875 by apply the sigma Fi condition at here. So we got this value RA. Now we know that this is the UDL. It means this will cross somewhere. So there is some contrast here. So again first here draw the shear force diagram for the simply supported beam. What is here? Shear force diagram for simply supported beam. Okay, so here we should draw here this. Now we know this RA is 46. Here RA is 46.875. Now at here we know from left side upward is positive. So this value is positive. Now up to this is a constant. So is a constant. This value is 46.85. And at here now shear force at left of the RB, that is how much? 103. From the right side upward force is negative, so that is minus here, and this value is 103.125. So now join this. So this is the contrast shear here. So now suppose this length is x and this length is 5 minus x, because total is a 5, so this length is 5 minus x. So by applying here the x divided by 103.125 is equal to 5 minus x divided by 46.875. So we will get here x is equal to 3.43 meter. So this value becomes 3.43 meter. Now we are able to draw the free bending moment. So for this, now we know bending moment at A and B is equal to 0 because of simply supported. Okay, then we have to find out the bending moment at here also, and then at the contrast shear. So at here bending moment at 3 meter. Suppose a bending moment at 3 meter. So that is equal to at here. We take it from the left side. So that is 46.875 into 3. So that value is 140.625. Then bending moment maximum where the shear force is 0. So at here shear force is 0. So we are taking it from the right side. Suppose at here this is our x, that is 3.43. What is here? This RB into 3.43 minus this UDL. So RB is how much? That RB is equal to 103.125 into 3.43, okay, minus 30 into 3.43 square by 2. If you calculate on the calculator, so this value becomes 177.24 kilonewton. Okay, so now we can draw here the free BMD. Suppose this is our beam. Again we draw here the beam. This is our beam. Now this is the UDL. Okay, so we are drawing here the free BMD. So now here now transfer this point. Again suppose this is the distance is 3.43. So transfer this point here. So at here is how much? 140, and here is a 177. So we know this is a linear, and this one is a parabolic. This height is 177.24. This is 140.6. Okay. Now this becomes a free bending moment diagram. Here we have to superimpose the fixed BMD. Now we know here at the A is 83 and at the B is 135.70. Both are in the hogging nature. So superimpose here this hogging, or we can draw here separate diagram. Suppose is A. This is 83. This is 135.74. This is hogging because of negative because of hogging. So we have to superimpose this diagram over this diagram. So this becomes like this. This is the 83 means is somewhere here. 135. So below that is somewhere here. So now this becomes the superposition. So this part, remaining part is minus, and this common part get the cancel out, and this part is the plus. So this is the, now this become free BMD becomes the BMD. Now remaining is what? Shear force diagram. So calculation of SFD. Again here consider previous one shear force diagram is only for the simply supported. Now we are considering this fixed end moment here. So again we redraw this beam like this. kN per meter. This is 83 and this is 135.74. Now here is A and this is B. If we, this is 5 meter, this is 3 meter. Again find the reactions here by considering the external moment. So sigma m is equal to, so clockwise positive, anti-clockwise negative. So this is anti-clockwise, so minus 83. Then this will create the second element clockwise, this is second clockwise, plus 30 into 5 into the resistance is 3 plus half of this, so 3 plus half of this is 2.5, this becomes a 5.5, and then this movement is again the clockwise, so plus 135.74, and this becomes the, suppose we are considering upward, so that is why is minus RB into 8 is equal to 0. So here this RB becomes 109.71 kilonewton. Okay, so if you apply sigma FY condition, this RA it becomes 40.29 kilonewton. So these are the our reactions for the shear force diagram. So now if you draw here, now this RA here becomes what? 10. Suppose if you draw here, R is 40, so is 40. Now here up to this is constant, $40.29, and from here we know there is 109.71. Join this. This is plus, this is minus 40.29. So this is the SFD, final SFD, and this is diagram is the final BMD. Okay, thank you.